Hello, welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video we continue our look at functions and we're going to talk some about using functions as part of problem decomposition. So in the last video we wrote a function that called quadrant that was supposed to return to you give it a point x and y, and it's supposed to return to you an int for what quadrant it's in. Imagine we have a problem where I want to calculate, I want to write a function now that calculates both the quadrant and the magnitude, as in the length of the line from the origin to the point xy. How would I write that? Well, one of the big changes in what I just said and what we wrote before is that this returns a single value, an int, and now I want something that returns two values. Now, how you approach that can be different in a lot of different languages. Scala actually makes it very easy. So let's go ahead and let's def quadrant and mag. Okay, I'll type in the whole word. And magnitude. And once again, we get a double for x and a double for y. And what are we returning here? Well, I want the quadrant, which is an int, and I want the magnitude, which is a double. Now, I've put them in parentheses here, and this is a type that you might recognize from earlier. For example, if I type in 3 and 3.14, I get back a tuple. Okay, this is a tuple of int and double, which is exactly what this is returning right here. So we've made a function that says it's going to give back two values, but it's going to give them back in the form of one single tuple. In a formal sense, you're only allowed to return one thing from a function, but it's very easy to make it so that one thing is a tuple, in which case it contains multiple values. And so I'll set that equal to something. Now, the question of what to do here. So I need to calculate both the quadrant and the magnitude. Well, the quadrant code is up here. So I could, copy these 5 lines of code and paste them down in here. But that actually goes against one of the main reasons why we want to use functions. That copying and pasting of code is something that you want to avoid, especially if definitely if you're not changing anything, but even if you're making small changes, it's better if you can try to think of other ways of doing it. And as we go through the book, you're going to learn more and more ways that you can get things done without repeating code. In this case, I want to do exactly this. Well, but that's what this function does. So instead of rewriting the code, I'm going to call that function. So this, when we call quadrant and magnitude, the first thing it's going to do is call quadrant up here and reuse this code and store it in a variable quad. By reusing the code, I make it so that if I find out I messed anything up in here, all I have to do is change this one function instead of multiple copies of it. In fact, the ideal functions that you would write are things that can be reused multiple times. I also need to calculate the magnitude. And the magnitude, we're going to use the standard Cartesian magnitude of the square root of the difference in x, or the square root of the x value squared plus the y value squared. So we'll call math.sqrt of x squared plus y squared. Okay. And now what I'm supposed to return is a tuple with two of these. And the standard way of writing this is to put them in parentheses. Now let's remind ourselves of this. You might recall there is another way of creating a two-tuple. This is not one of the situations where I would use the arrow notation to create a two-tuple. There are situations where it is a very helpful way of doing things and it has more meaning, but in this case I kind of prefer the percent. Now, what if we were to run this, and I've changed it so the print line prints out this new function for us, and I enter a, let's actually go with an easy one, 3, 4. It's in the first quadrant and it has a magnitude of 5. One of the things when you're testing code, I always tell students, the first time you, or when you're testing code, one of the most important things is that you know the answer. If you don't know what answer to expect, the program can spit out pretty much anything and you won't have an idea of whether or not it's correct. You should, now maybe if I had done 5 and 6, well, okay, I couldn't have told you off the top of my head exactly what that is, but I could think about it and say that that is roughly the right magnitude, and it is still in quadrant 1. But it is nice to do a test case where you know exactly what the value is so that when it outputs it, you can tell whether or not it is correct. Now this is printing it as a tuple, so we get standard tuple formatting. What if I want to print them out separately and I want to say something like it's in quadrant 1 and it has a magnitude of blank? Well, then I would need to make some variables. Now I could make a single variable, I called it QM here for quadrant and magnitude, that is the tuple, and then I could, one way of pulling things out from tuples is to do the _1 and _2. I really don't want to do that. This form, while it's fairly short to type, and there are times when it's nice, as I've mentioned before, quickly becomes unreadable because this ._1 has no meaning to it inherently. So instead, I am going to use the form where I pull out the values of the tuple on creation of the variable using what's called a pattern. And I am going to create variables named quad and mag, and then down here it occurs to me, people with experience who watch this video might wonder, why isn't he doing like polar to Cartesian? Oh, there's a very good reason for that. That's an exercise in the book, and so I'm not going to give that here in a video. There are certain problems that are very standard for you pass in multiple values and you get out multiple values, and they're very good for illustrating that. So this uses this pattern matching, creates two variables. They automatically get bound to the two values in the tuple that this returns, and then I can print them out. And so if I do the 3, 4 again, it says the point is in quadrant 1 and the magnitude is 5. And just to check, -1 or -3 and 4, now it's over in quadrant 2 with the same magnitude. Okay, so that is a simple example of a function that returns multiple values to us through the use of a tuple. And then how we can get those values by doing an assignment into a pattern when we create our variables. Now, the question of why do we use functions is an interesting one. In some ways, this example, part of the reason I like this example is it shows part of that. The ability to reuse this quadrant function later on is significant. Another example that it's kind of standard, and I'm not going to write real Scala code here because, well, I don't know if you could. So I'm going to call it a text file. PB&J. For most Americans, that will automatically tell you, oh, we're going to write the example of making a peanut butter and jelly sandwich. The reason for using functions is that you can break a problem down into pieces. So, for example, at the top level, I might have, and so I'm going to write Scala-ish stuff here. It's not going to be real Scala. Make PB and J, which would be just a function that does something for us. Maybe it could actually give us back a sandwich. some type that it does not exist in Scala, though, as we will learn later on. We could make this type for ourselves if we chose to do so. And I won't bother writing the body of this function, where it equals something or another. But, well, actually, I guess in this case, maybe I will. How do we make a sandwich? Well, this is in some ways, when I say this, you might find it funny. This is a complex problem. It has multiple steps in it. And a lot of the programs that you wind up doing have this type of nature to them. In fact, once again, one of the real advantages of learning how to program isn't just the ability to program, though that is becoming increasingly important in the modern world. One of the even more significant aspects of it is the ability to learn how to work with problems and break things down. So when I think about making a peanut butter and jelly sandwich, I first level break it into some reasonably large pieces. So for example, get ingredients would be a piece. Combine ingredients, put stuff away. Okay. Now, in writing it this way, of course, these wouldn't be things that are built in to Scala. Each one of these steps is itself fairly large. And what I'm doing here is called a top-down approach to problem solving. I start with the top-level problem, the make a peanut butter and jelly sandwich, and then I break it into pieces. Now, those pieces might still be reasonably large, and so I have to break them down as well. So the first function we had in there was get ingredients, which would return some stuff. And to get the ingredients, in this case, get bread, get peanut butter, get jelly. And this would probably need to return all three of them, and dealing with exactly what syntax we want and how we're going to have tuples with that kind of goes away from what I want to stress here. But I've taken this and I have broken it into three parts. Now, these could each be separate functions. However, you'll notice that in this case, each one of them has a certain similarity. They would all, if it were written correctly, you're getting something in all three of these cases. And so it might be helpful and possible to reuse this. Maybe we could have this so that we were going to get the bread, get the peanut butter, get the jelly, and then this might be a function to help it out. We would pass in another argument that is where you're getting it from. Okay? And in fact, we might pass in some other things. But the idea here would be to make it so that we could write one def get, which takes what to get and where to get it from, and then gives us back stuff. Okay. And now this one function has been reused multiple times. The next function that we called in here was combine ingredients, so we'd have to define that. We would also have to define put stuff away. Okay. And each of these might have other steps in them with which wind up being written as other functions. So this is what's referred to as a top-down decomposition of the problem. I started at the top-level problem, the biggest thing, and then I broke it into some large pieces, and I break each of those large pieces into smaller pieces, and I continue breaking these pieces down until I get to something that's easy. And for me, this is one of the center points of computer science and the whole act of programming. The way I tell this to a lot of my students is never solve a hard problem. Okay? If you are given a hard problem to solve, break it down into easier problems. Okay? And continue breaking it down until you get to easy problems. I've actually had students lament in their senior year when they're going and looking for things for a portfolio. I wanted to find something really complex, but I never did anything complex while I was an undergraduate. To which my response is, good. Okay. If you did something, and especially after solving it, you look back on it, you're like, whoa, that was really complex and hard, that probably means that you didn't do a really good job of breaking it down into pieces. If you break it down well, at the bottom, you're always solving easy problems, and then you're taking those easy solutions and you're putting them together, always in fairly small steps. Okay, so that's what you really should be aiming for in this. Now, along with the top-down problem decomposition, there's also the idea of a bottom-up. So, for example, when you started writing this, you might have written the make PB and J, and then immediately said, okay, well, I've done this type of thing before. Maybe I had already solved something where I was making a ham sandwich, and I know that I'm going to need this get function. Okay? And so you might go ahead and write one of the low-level functions and then use it to build stuff up from the bottom. In real software development, you kind of alternate between the two. I would say that the top-down is what you do most of the time. In fact, it's very common for me, and later on in these videos you'll see this. I'll just make up a name of a function, just like I did here, where I type in get ingredients, or I'll make up the name of a variable and just assume it exists. And the thing is, if I forget to write it, when I come over here and try to run it, it'll tell me that. It will give me an error. But I will have it kind of in there as a placeholder and to help me remember stuff. And to organize my thoughts, because really organizing your thoughts and figuring out how to approach the problem is one of the biggest aspects of computer programming. And functions help us to do a lot of that organization. So that's it for this video. See you again soon.